We are in lesson 11.2, probability distribution. First part, discrete random variable. So a discrete variable is one which can take values which are distinct and discrete. They are usually integer values. To understand what I'm saying here, guys, I will give you an example. Let's say in a class we have 25 students and we are choosing 3 students, and I want to make a condition for choosing these students. I will say let x be the random variable equal to the number of left-handed students chosen. I'm choosing 3 students, but I really want to count what is the probability of having one student that is left-handed. So what's gonna be the values of x, the random variable? Out of those 3 students that I'm choosing, I could have 0 left-handed, I could have 1, 2, or 3. I cannot have more than that. And all the time when I'm doing the probability distribution, the sum of all the probability should be equal to 1. So let's do an example. The probability distribution function of a discrete random variable x is given by, let's say I have this probability distribution of x equal xi 1 over kx squared. And I have x equals 0, 1, 2, 3, and 4. Complete the probability distribution table, and I need to find the constant k. First of all, I need to make a table. It means I need to put for x equal to 0, 1, 2, 3, and 4. So this is the probability distribution. I wrote it here. So for x equal to 0, what's going to be the answer? 0 over k, it's 0. For x equal 1, 1 squared over k, it's 1 over k. X equal to 2, it's 4 over k, 9 over k, 16 over k. We know that the sum of all those probabilities should be equal to 1. So I will add equal to 1, and then I will solve for k, and I will get k is equal to 30. Let's move to the second question. Find the probability that x is less than or equal to 2. When I say less than or equal to 2, it means I want to add all the probability less than or equal to 2. It means it's p of x equal to 0, 1, and 2. Already I have k, I can replace it, and then I will add them, and the answer is 5 over 30. Let's move to the third question. Find the mode of the distribution. The mode is the value of x that have the highest probability. Which one has the highest probability? It's 16 over 30, so the mode is 4. And if you draw it here, you can see that for x4, I have the highest probability here. And the last question presents distribution with a vertical line graph, so you can see it here. So you put x here on the x-axis. I have 0, 1, 2, 3, 4, and then for each one I will represent y as the probability, and I can graph it. Second part, expectation Ax. Expectation defines the value you would expect as the number of trials increases. First, how do you find the expectation? It's the sum of x times the probability, and also we can write it as mu. To understand what this means, expectation, let's do an example. I have this example here. I'm still in the same example. In a class, we have 25 students, and I have 5 are left-handed, 20 are not left-handed. 3 students are chosen, and let x be the number of left-handed chosen students. So what are the possible values of x? 0, 1, 2, 3. So how are we going to find the probability distribution? When I say p of x equal to 0, it means out of those 3 chosen, I have 0 left-handed. When I have 0 left-handed, so I need to pick the 3 from the not left-handed. So it's C320 over C325. Now, 1 left-handed, it means I will take 1 from here and 2 from here. So it's C15 times C220 over C325. 2 left-handed is C25 times C120 over C325. And 3 left-handed, so it's C35 over C325. If I add all those probabilities, the answer is 1. How do you gonna find the expected value? We do 0 times 57 over 115 plus 1 times this one plus 2 times 2 over 23 plus 3 times 1 over 230, and I'm gonna get 0.6. What is the meaning of 0.6? The probability of, for example, if I am choosing 3 students, the probability of having a student is left-handed is 0.6. So I'm expecting, what is the probability of having a student with a left-handed? This is the this is the important part of E of x. Let's move to the part 3. Expectation for a linear function of a discrete random variable. If a and b are constants, a not equal to 0, and ax plus b is a new random variable derived from the discrete random variable x, then what's going to be the expected value of ax plus b? We know that the expected value is the sum of the values axi plus b times the probability. So it's equal to the sum of axi pi plus sum of bpi. So it's a ex because xi times pi, the sum, this is ex plus b. Let's do an example to understand what I'm saying here. So a game is developed such that a die is thrown and the banker pays out 3 times the value in dollars of the score on the die. How much would you pay to play this game? First, I'm gonna do the probability distribution, the table of throwing the die. The die that is 6 faces. Okay, so to get 1, 2, 3, 4, 5, 6, I will have each probability is 1 over 6, 1 over 6, 1 over 6, 1 over 6. Now, in order to look at this question, it's important to construct the probability distribution table related to what they said here 3 times. So if x is 1, 2, 3, 4, 5, 6, y is equal 3x, so it's gonna be 1 times 3, 2 times 3, 3 times 3, 4 times 3, and this is my distribution table. Now, if you find E of x here, the expected value for the first table, the answer is going to be 3.5. So it's 1 times this plus 2 times this. So you know this formula. Now let's find the expected value for the new variable that's related to the preceding value. So this is what I was saying here in the definition. They are related. It's derived from it. So this is derived from it. So if I calculate the new expected value, it's 3 times 1 over 6 plus 6 times 1 over 6 and goes on. So the answer is 10.5. So if I link 3.5 and 10.5, it's times 3. So it means they have a relation. So if I have the expected value for the first function and I need to get the 1 times 3, so it's just very simple. I just multiply the expected value by 3. So if I want to answer the questions here, how much would you pay to play this game? The banker would expect to pay $10.5 to play this game. Now let's move to the variance and the standard deviation. So what we're gonna use directly for the application is this formula. So we know that the variance is the square root of the standard deviation. It means the standard deviation squared gives me the variance. So it's ex squared minus ex all of it squared. So let's do an example. 2 discs are drawn without replacement from a box containing 4 blue discs and 3 red discs. So I have 4 blue and 3 red. If x is the discrete random variable, the number of blue discs, so I'm just working about the number, I'm counting the number of blue discs drawn. So I could have 0 blue disc drawn or 1 or 2. Construct the probability distribution table. So if I want to construct the probability distribution, I need to find probability of getting 2 blue discs. So it's C24, C27, 1 blue disc, so C14 times C13 over C1, C27, and 0 blue disc, it means I got 2 red, and those are the answer. I have this probability distribution. How are we going to find E of x? So it's 0 times this one plus 1 times this one plus 2 times this one. So we're going to see it. It's here. How do you find ex squared? So it is 0 times 0 squared times 6 over 42 plus 1 squared times 24 plus 2 squared over 12 over 42, and I got it. And now we're going to find the variance. It's ex squared minus ex all of it squared. We got ex squared from here, and we have x from here. We square it, and we get the variance. And how do you find the standard deviation? It's the radical of the variance. So that's it, guys. It's just about calculation all this lesson. See you in the next video.